Okay, so it is given that it is a small manufacturing. Yes.
Sir.
Problem that it is a small. Sorry. Yeah. It's a small manufacturing plant, or it's a small manufacturer. Okay. So it's a small manufacturer, so making products. So product A and product B. And product A is using the resources R1 and R2. Same way, product B is also using the resources R1 and R2. Okay. So if a product A has to manufacture, it requires 1 unit of R1. So it is something like a raw material. So 1 unit of R1 and 3 units of R2, if you combine, you can get one product of A. Similarly, 1 unit of R1 and 2 unit of R2, if you combine, you will get 1 unit of product B. And the manufacturer totally has 5 units of R1 and 12 units of R2. Okay, so this is the constraint. So constraint on R1 is limited to 5 and 5 and R2 is limited to 12. Okay, so manufacturer makes a profit of 6 units for product A and 5 for product B. Okay, so formulate the objective function and the constraint. So that is the question. Okay, so now the first step, the step number 1 will be identify the, so step 1 will be to identify the decision variable. Okay, what are the decision variables here? What are the decision variables given in the problem? What are the decision variables?
R1 and R2?
No.
So then X1 and X2, that a number of products.
Yeah, exactly. So the decision variable here is that number of products of product A and number of products of product B to be manufactured. So the decision variables, I can say that number of products of product A to be manufactured, same way number of products of product B to be manufactured. Okay, so the first one, I can say that the number of products of product A to be manufactured, that is X1. Okay, and the number of products of products B to be manufactured is X2. Okay, so the step 1 is over. So in the step 1, I have identified what is the decision variable is. So there are 2 decision variables given in the problem. There are 2 products has to be manufactured. So the number of products of product A to be manufactured and number of products of product B to be manufactured. So they are the decision variables. Now what is the objective? Now the step 2 is to formulate the objective function. What is objective function here?
resource should be limited between 5 and 12 and maximize the profit.
Okay, so the objective function of our problem is to maximize the profit. So step 2, okay, formulate the objective function. Okay, so objective function is number of x1 units. Okay, so is to the formulate the objective function. So what is the objective function? So objective is to maximize the profit. Is to maximize the profit. So when will be the profit will be maximized? So how will you get the how can you get the profit statement from here?
6x1 plus 5x2 is maximum value.
Yeah, exactly. So the maximize the profit. If you want to maximize it, you can say to that if we the cost of selling 1 unit of x1, that is product A, is 6, and the cost of selling one product of B is 5. So if you add 5 into x2 plus 6 into x1, if it is maximized, you will get the maximum profit. So I'll write it as equation. I'll write it in the equation form. Yeah. So I can say maximize z equals, okay, 6x1 plus 5x2. 6x1 plus 5x2. So maximize z equals 6x1 plus 5x2. So that will be the objective function. Now,
Sir, one doubt, sir.
Yes,
but we
please.
should consider resource also between that x1 and x2.
I'll come to it. I'll come to it. Okay. Okay. Now the next step, step number 3. Okay. Step number 3 is to, okay, formulate the constraints. Okay. Formulate the constraints. Navi, can you unmute your mic? Yeah, okay. The next step number 3 is you need to formulate or you need to identify the constraints. So what are the constraints here?
The available resources R1 and R2.
Available resources of available units of resources R1 and R2. Okay, so the constraints are, we can say that it is available resources of R1 and R2. Okay, now how the R1 is how the R1 is given. Now how to formulate
plus
for
3x2
R1?
less than 5 is an equal to 5.
No.
x1 plus 3x2.
No.
X1 plus x2 is equal to 5 and 3x1 plus 2x2 is equal to R2, R12.
Equals 12. Okay, but that constraint side you have to take into careful, you should not exactly equate to 5 or it should be exactly equate to 12.
So less
So
than
it
equal
should
to.
be, yeah, always it will be taken as less than equal to. Whatever you have told is correct. So you can see this is the way in which, okay, so this is the way in which the R1 is connected. So R1 product A, it requires 1 unit, product B, it requires 1 unit, and maximum unit available is 5. So you can go to the constraint equation. Okay, so you can say that x1 plus x2 less than or equal to 5. Constraint number 1. What's the next constraint? What's the next constraint?
3x1 plus 2x2
Yeah.
less than 2.
Yes, same way. Okay, same way. You can say 3x1 plus 2x2, okay, is less than or equal to 12. So this is basically product A, we have taken it as x1, product B, we have taken it as x2. Okay, so you can see this is how I am formulating the constraint. So this gives my constraint 1, this forms my constraint 2. Okay, so here I have taken x1, x2 less than or equal to 5. So R2, it is 3x1 plus 2x2 less than or equal to 12. Okay, so the next constraint, it will be 3x1 plus 2x2 less than or equal to 12. Any other constraint or any other data is given in the problem? Any other constraint or any other data is given in the problem? No. Okay. Now what else to be done? What is the
Non-negativity constraint.
Yeah. So you have to add the last thing, the step number 4. So step number 4, that will be adding non-negative constraints. So what is non-negative constraint? What will be the non-negative constraint?
x1 greater than or equal to 0, x2 greater than or equal to 0.
Yeah, exactly. That is, our decision variables should be greater than or equal to 0. So it will be x1 comma x2, okay, greater than or equal to 0. Okay, this is what is called as, this is the end of your formulation of LPP. Formulation of LPP. Okay, now you have the mathematical equation for the given problem. Okay, I will just repeat from the first. I'll just show you the problem once again so you can see an idea. So there is a small manufacturer. He is making two products A and B. Okay, he is making two products A and B, and he is using two resources R1 and R2. Okay, and product A, the unit cost of producing, okay, the R6, the profit by selling 1 unit of product A, the manufacturer will earn ₹6, and by selling product B, he will earn ₹5. So using that, I can understand that it is to maximize the profit. The problem is to maximize the profit. So profit will be maximized when he sell as number of units of product A as we have taken as x1, and as many products of x2, that is we are taken as x2. Product B we are taken as x2. So the profit, the total profit by selling product A will be 6 into x1. and product B will be 5 into x2. So that is what I have written over here. Yeah. So that is what I have written over here. The first step, identify the decision variable. So we identified the decision variables as number of products of product A to be manufactured and number of products of product B to be manufactured. So number of products of A to be manufactured I have marked as x1 and number of products of B to be manufactured I had marked as x2. So next is to formulate the objective function. So the problem is to maximize the profit. So we will get a maximum profit. So by this 6 into x1 plus 5 into x2, you have to maximize it. But that maximization is subjected to the constraints. So the constraints available in the problem is in the form of resources. So resource 1 is the resource R1 is the resource R1 is limited to 5 and resource R2 is limited to 12. So R1, how the requirement is going? So R1, for making 1 unit of product A, 1 unit of R1 is required. 1 unit of B, it requires 1 unit of R1. So I am just putting the constraint like this. Okay, this is my first constraint, x1 plus x2 less than or equal to 5. Second constraint I am formulating again based on the similar idea, 3x1 plus 2x2 less than or equal to 12. And finally I am writing the non-negativity constraint, that is my decision variables. That is, I cannot make a negative x1 quantity, okay, or negative x2 quantity. So I am writing that x1 comma x2 greater than or equal to 0. Okay, so that is the end of your formulation. This is how we will formulate the problem. Okay, so we can discuss here further. Is it clear? Any doubts or any issues is there, we will discuss. Anything if it is not, since this is the basis of the subject, how to formulate it. Anything to be discussed or anything to be cleared, we can discuss here. Is that clear?
Yes, sir.
Anybody is having any doubts?
No, sir.
Clear. Okay. If that is the case, the second problem. Yeah, it is the same. So the same way it is just for your information, it is just formulated like that. The same way we have already solved it. So this is how it is represented in another manner. That's all. I hope that is
Sir,
clear.
one doubt,
Yeah,
sir.
please.
Sir, when R1 and R2 can be taken as decision variables, means in what case?
R1 and R2 are not at all your decision variables in the problem.
Yes, sir, but in what type of question R1 and R2 means here profit means in which cases?
You need to optimize R1 and R2. Resource optimization. Okay.
Okay, sir.
Yeah, resource optimization. In that case, you can take it in that way. Okay, but here we are not optimizing the resource. That is, you will be getting resources from various places. Okay, and you need to find from which resource to which location it has to be sent, something like that. A resource optimization, if it comes, then the resource will be your objective function. I hope it clarified.
Yes, sir.
Yeah. Any other doubts? Any other doubts or anything to be discussed? Now, how to find the values of x1 and x2?
By plugging in some numbers.
Eh?
By plugging in some numbers for x1 and x2.
Okay.
Sir, using graphs we could do, sir. Plotting
Yeah.
graphs.
Differentiate it, so differentiate maximum equal to 0, maximum will get.
We can solve the constraint equations. Instead of less than or equal to, you can just substitute equal to and you can get values.
Yeah, okay, right. So now if it is a two variable problem, it is easy to find the solution graphically. Okay, it is easy to find the solution graphically. Okay, if it is more than two variables, you have to convert the, the inequality constraints into equality by adding additional variables, and then you can solve it by using simplex method. Okay, differentiating part we will not solve for the linear programs, that normally we will do for the non-linear problems. Okay, there are specific methods are there differentiating with respect to the differentiating it by certain peoples have developed it, so it is known in their names. Okay, so the linear systems of equation, it is better to solve the things with the help of graphical. Now graphically how we will solve? So it is a two variable. Okay,
Sir, area under the curve, less than equal to 5 means draw one.
I'll come to it. I'll come to it.
Intersection of the two equations.
Yeah, I'll come to it.
Sir, excuse me, sir.
Please.
Sir, or else
Yes,
we could we could take the two equations, sir. Instead of lesser than equal to, we could take it just equal to. Plot the graphs. If it's given lesser than particular value, no, sir. So it will be going towards the origin, sir. So we could change the area and we could get it, no, sir.
Yeah, we can do that. I'll come to it. We'll solve graphically. Graphically is the easiest method to solve it. Okay. So I had the two variables. One is x1 and the next is x2. Okay, so the equations what I have got is x1 plus x2 less than or equal to 5. Okay, so x1 plus x2 less than or equal to 5, and the second is 3x1 plus 2x2 less than or equal to 12. Plus 2x2 less than or equal to 12. Okay. Right. So now we take the first equation. So first equation, so I will say that this is x1 and this is x2. Okay. Now we'll take the first equation. So x1 plus x2 less than or equal to 5. So first substitute the value of x1 as 0. Okay. This is 1 and this is 2. So take the first equation, we will solve it. So by substituting x1 equals 0, what we will get? We will get the value of x2 as
less than 5.
okay, s2 as 5. Okay, now substitute the value of x2 as 0. Then we will get x1 as
5.
5. Okay, so I'll just mark here on the thing. Okay, so this is 1, 2, 3, 4, 5. So this is the point where the second case x2 is 0 and x1 is 5. Same way here also. Okay, so this is the point. Now joining these 2 points, I will draw a straight line. Okay. Now which search direction I will go, whether I will select this area or I will select this area, into or minus, which area I will select?
Minus. Towards the origin, sir. Origin.
Why?
Well, because it's less than or equal to, sir.
Yeah.
So values can be less than 5.
So yeah. So if it is of less than sign, okay, the search direction or the area, you have to select it towards your origin. So now this is your feasible region. This region is the feasible region for the constraint number 1. Okay, right. Now similarly solve for equation 2. Okay, similarly solve for equation 2. What you will get? If you substitute x1 as 0, x2 will be
0, 6 and 4, 0.
x2 will be
No, the 0, 6, I think.
x2 will
X2,
be
6.
6.
6. Okay. Now substitute x2 as 0. You will get x1 as
4.
4. Okay. So I'll just mark it. So initial case x1 is 0, x2 value is 6. So it will be here as 6. So this is the point. Now the x2 I have marked. Okay, next x2 is 0, x1 I'll get it as 4. So this is the point. Okay, so now again join a line, join a straight line. Okay, what will be the search direction? What will
Below,
be the
no, same thing. Below.
Toward origin.
same thing? Okay, that is here also the search direction will be towards the origin. Yeah, right. Now you can see there are many spaces are formed by the constraint. Now how I will find the solution? I have region 1 is there, region number 2 is there, region number 3 is there, region number 4 is there. Where will my solution will
Region
lie?
1, sir.
Region
1.
1 or any other region?
Only 1, sir.
Only
Take
one?
intersection of areas, intersection of both the areas, so there will be only 1.
Yeah, exactly right. So the feasible, so 1 is called as feasible region. Okay, 1, the region number 1 is called as feasible region. Okay, and all other 2, 3, 4 are infeasible region. So feasible region, you will have, okay, you will have many points. So this is point number A. You will have point number B. You will have one point here, point number C. You will have point number D. This is another point, point E. This is another point, point F. Okay. So feasible region is marked with the point A, B, C and D. They are also called as bounded feasible points. Okay, they are also called as bounded feasible points. And point number E and F, okay, E and F, though they are bounded, they are infeasible points. Okay, though they are also bounded by the constraint, so they are also bounded, but they are infeasible points. Okay, now you will have the coordinates for A. Okay, A, you will have the coordinates for X and Y. B, you will have the same. C, you will have the same. Then D also you will have the same. What is the coordinate of A? A is 0, 0. B, what is the coordinate of B? X1 is
4, 4, 0.
4 and Y is 0. Coordinate of C,
C is
I think it is 2, 2. I'm not sure.
2, 3, sir.
2, 3. Okay. And yeah, 2, 3. Right.
Sir, X comma Y, or you are saying X1 comma X2, sir?
Pardon me?
Is it X comma Y are plotting, or X1 comma Y, X2?
X1 X2. Okay. So 2, 3 and D it is point number D it is 0, 4.
5,
Now,
4, 5.
0, 5. Okay, sorry.
5.
0, 5. Now substitute these values, substitute these coordinates in your objective function. Okay, substitute these coordinates in your objective function. Whichever satisfies your objective criteria, that will be the solution for your problem. This is how we are solving the simple problems graphically.
Sir, one doubt, sir. Like
Yeah.
here we have two products. Like no, two products, X1, X2, number of products. If there are some 10 products or so, we cannot do it graphically. No.
10 products, if it is there, we can't do graphically. We have to go for simplex method. Only two variables, two decision variables, if you have, you can go graphically. Now substitute this in the objective function and get me the result, which is the optimum one.
2x1 and 3x2, sir.
2x1 and 3x2.
3x2.
Okay, so what is the output you are getting?
Profit will be 27.
Profit will be 27. So you can see that two products of x1 and three product of x2, if you are selling, you will get a maximum profit of 27. Am I right?
Yes, sir.
Yeah. So maximum profit will be equal to 27. Is that clear? Is the methodology clear?
Yes, sir.
Yeah. So yeah. So what you want to do? So what I want you to do is that take a graph sheet and try to plot this in graph sheet. Okay, and bring it to the next class. Bring it to the tomorrow's class. Okay.
sir.
Yeah, so everyone has to plot, everyone has to, I think morning you have taken the copy of the question. So behind the graph sheet, you can write all the decision variables. You can write all the decision variables and please plot this in the graphical graph sheet, and please let me know that you are getting the same result. Whatever I am just writing in this board, I can share this also with you for your reference. Whatever I am scribbling in the board, I can share with you. I think that I can share it in your WhatsApp. Will that do, lad?
It's fine, sir.
Yeah, so C batch I am there in your official group. D batch students can, D batch reps can add me into your group. So I can share with you also. D batch rep is there.
Yes, sir. We'll do it, sir.
Yeah, so you can add me into your group so I can share these pages also with you. Okay. So is the step is clear? Don't worry, we will practice some more problems and we will practice some more variety of problems also. Don't worry. So solve this problem and we will see on tomorrow in the tomorrow's class. Any other doubts if you have, we can discuss.
Sir, what if the points like B, C, and D are fractional?
B, C and D?
D, if example, the points are like fractional points, not whole numbers.
It will not, normally you will not end up in the fractional results in the case of linear program. Okay, if we are getting it as a fractional results, you can round off to the next digit. When you are solving simplex, definitely you will get, okay, graphical thing normally I have not observed it. Simplex we have seen it, you can round it to the next digit.
So should we round it to the lower value or lower value always?
No, if it is great, normally if it is greater than 0.5, we will round it to the next digit. Less than 0.5, we will ignore it. Okay.
Okay, sir.
Okay.